Planet-Friendly Web, warum unser Web nachhaltiger werden muss und wie wir das anstellen. Und euer Referent ist der Niklas. Er gibt euch einen kurzen Einstieg ins Thema Klimawandel und welche Beziehungen zum Netz da bestehen und wie die sich ergeben. Einen großen Applaus bitte für Niklas. Dankeschön.
Warm round of applause for Niklas. Thank you. Thank you. Thanks that I can be here. So today we're talking about the planet-friendly web. Which effects does the internet have on the environment? And how can we change them and how can we minimize them? But before we start, we have to talk about this. This is a picture by Professor Julia Steinberger. And with this illustration, she tried to explain to 4 to 8-year-olds what climate change really means, what greenhouse gases really do. And it was really interesting to me how easy it can be portrayed. So, in principle, it is like this. We have an atmosphere around our Earth, which also makes sure that our Earth does not get obliterated by the sun, but also keeps us warm. But the more greenhouse gases we emit, the more foil we wrap around our Earth, and the more rays can get in and the less much less can get out, so our Earth gets hotter. This means that as our Earth gets hotter, the water cycle will change. Even more water will become part of the atmosphere. The issue is that this will create things like this. Studies have shown that the climate change will not only increase the number of climate catastrophes like hurricanes, but also increase the intensity of these catastrophes. So a warmer atmosphere and more water in the atmosphere, hurricanes will get worse. So we will feel this, for example, with Hurricane Dorian in the United States of America. So a show of hands, who has seen this before? These are the climate strides. Oh, a bunch of people, that's nice. For those who haven't seen it before, this is the visualization of the last 100 years. What you can see is 100 stripes. Each stripe represents 1 year and shows the average temperature in this year. The more red the stripe is, the warmer that year was on average. And you can clearly see, this is the climate stripes version for Germany, and you can see the last 100 years, and in the last quarter, the average temperature has risen significantly. So if we're talking about the climate crisis, we're not only talking about the Philippines or other countries which are far away, but we are also affected by this right here. So talk to the forest keepers. They are already noticing the effects in their everyday life. And we, in our everyday life, or most of us, they are aware of this. They try to act sustainably by, for example, purchasing organic products. They're not buying coal energy. They might ship parcels climate neutrally. So these are things that we do actively in our everyday life because the environment is important to us, but not in our professional life. So this most often doesn't go beyond, please think of the environment before printing this email. Most of you have probably seen this before in some email from some company. For many, this is the only connection between environmental protection and their professional life. Who of you has seen this on a website before? Show of hands. So less hands here. So in signatures, we can see text like I've shown previously quite often, but this here is not so common. A radical example of a website that does it differently is the Low Tech magazine. I don't know who of you knows this, but you can see this yellow area here. The yellow area shows how much battery the server has left. The server is only powered through solar energy. Collected at some balcony in Barcelona. There's a little Raspberry Pi there with a solar panel attached to it. And if the sun is not shining for a duration that's too long, then this will be reflected here on the website. In the footer, you can see some uptime statistics. 2 weeks are left if the battery is depleting. For example, if the sun isn't shining enough or too many people are reaching out to load this website.
We often talk about flying less because flights are very harmful to the environment. There's 830 million tons of carbon dioxide caused by the flight industry globally. But the thing we talk and think about less is the internet, which emits roughly the same amount of carbon dioxide. It's said that until 2020, the internet is going to emit twice as much as flights. But we never talk about this. We never talk about changing our streaming behavior. We never talk about if we really, really need that website with the big pictures, but we mostly talk about flights. And this is what I'm trying to change with my talk today, because we need to keep in mind that the internet is made up of data. Data is essentially electrical impulses, and those need energy. And energy production causes greenhouse gases and carbon dioxide specifically. This is a very simple formula we need to keep in mind when we code websites or develop digital products. Data as energy is carbon dioxide. I think most of you are aware of how the internet works. But not so long ago, when advertising was printing flyers or magazines were printed, this was a difference. Back then, we had the printing process, which used resources once. Then we had to distribute that, and that was transport, paper, etc. Then it doesn't matter how many people read this newspaper or how long it stays in our cupboard, it doesn't use any additional resources. It's different with digital products. Digital products use the most energy when they're being used intensively. For example, because packets are being sent to the DNS server, to the web server, and then they're getting sent back. All this uses energy, and the more people use a product, the more energy is used and is needed. What we need more of is cool people who think about making our products more sustainable. We often have people who really, really think hard about how the economic sustainability. We also have people who are concerned with the search engine ranking of the page. We have people thinking about, at best, the accessibility of the page, but which we don't have today are professional people who are concerned with the sustainability of a site or how it might be designed more energy efficiently. So which features might need less energy than others? We need more of this. And in the next 30 minutes, you're going to get a crash course about this professional. I've distributed this talk into 3 parts. First part is about energy, which energy is used to run my page. Then there's about the resources I send. And then finally, we're about the responsibility towards our users. Before we start with that, let me introduce myself. I'm Niklas Jordan. I'm from Schwerin. And I'm very concerned with the influence of technology on the environment and on people, and the positive impact that can be made here. Let's start with energy. Energy is the most simple topic. Facebook started very early by switching their data centers to renewable energy. Then Google, Rockspace, and Salesforce joined them, but there's still products and companies who refuse that or aren't very transparent like that. Twitter doesn't publish any transparency reports which energy they use to run their data centers. It is estimated that the energy they use is about 35% renewable, and we need to change that. It's rather easy to see if a site uses renewable energy or not. There's the Green Web Foundation. If you call up a website, you see this screen. You can enter the domain there, and then you get results on whether they use renewable energy or not. Also, if you run a website yourself, then you can access a registry of green hosters. So if you realize your hoster doesn't use renewable energy, you can see who to switch to, who uses renewable energies, and move your website. If you've done that,
then you've already achieved a lot. So now we talk about the resources. Which resources do I send over the wire? So there's a really cool tool which helps us estimate how far I've already come. It's called Carbon Calculator. So I've done this for Wikipedia here, so you can just enter a domain and then you get a little report. So Wikipedia emits about 0.22 grams of CO2 per visit. They use sustainable energy, that's nice. And then if you enter the correct number of page views, then you get a calculation of how much CO2 is really being used up or created by this website, and you get some comparison values. The issue that we have is that we have faster and faster bandwidth, so we don't really have to care anymore about the size of a website. This graph shows how the average size of a website has changed over the years. Right now we are at 3.5 megabytes as the size of an average website. 2011, this looked much different. So if we look at the yellow area here, that's the HTML part of the website. That's the stuff that is actually relevant because it's the content. And that part is actually getting smaller instead of larger. So we have less content on our website. We want to say less, but our website is getting bigger. And that's because we're using more and more images, even more high-resolution pictures, more videos, and that's really not necessary because we don't have anything additional to say. Why should we increase the size of our website? A different aspect of this is advertisement. This is a graphic created by the New York Times, and it shows in yellow which part of the size of a website is actually advertisement on news website and which part is the content. That's the blue part, and you can see the absolute mismatch. You want to read an article, but first you have to load 15 megabytes of tracking scripts and all that sort of stuff before I can actually see the content that is only 4 megabytes in size. So there's definitely potential to optimize this. The large advertisement corporations like Apple, Google, and co, they're trying to change this a little, but at the moment there's just a huge mismatch. So not only is it important because of privacy and security to use ad blockers, but also from an ecological perspective. This is an example. It's webspeed.net, and you can enter an URL and see how much energy I could save with an ad blocker, how many requests, to just be able to evaluate how much is using an ad blocker really worth. Then there's also this nice tool for all of you who are programming websites themselves. This is really interesting. It's called the Performance Budget Calculator. Is any of you using, during the creation of websites, a performance budget? 1 to 3 hands are shown. Nice. So this is about defining that my website will load on an edge network within 5 seconds, for example. So that's my budget that I have, that I can translate to resources. So if I enter my goal here and the type of connection, and then how much time it should take to load this website, then I get an approximation of how much data I can put on my website, how much space I have for HTML, CSS, etc. And the advantage is that I have to really think about what I should put on my website and what I should not put on it. And this is really cool if you define this goal and then the customer wishes for a new feature, and then you can talk to the customer about it, and you can then say, we can do this, but then we will miss our performance budget, or we have to remove something else. So then you have a concrete measurement with this tool to work with. So I have an example here that I brought with me. 2 years ago, I was using a large German publisher with 4 letters as an example, but they didn't find it so cool, and they asked me nicely to please stop using them as an example. So now I'm using Wikipedia, who are much cooler. So I did some napkin math. So there are, of course, many more aspects, but I just wanted to show you the dimension of what we're talking about here if we change something. So I looked at the front page of Wikipedia. So what is loading each time I look at Wikipedia? And that's, of course, the logo. The logo, I downloaded this on my computer, and I checked the size, 45 kilobytes. Doesn't sound so large, sounds small. And then I checked this image with ImageOptim. It's a free tool for Mac, but there's also others, and it compressed the image for me losslessly, and you can see here a saving of 56.5% that you could achieve to end up with about 20 kilobytes. Wikipedia has 170 million page views per month, multiplied by the saving, 25 kb, and remove some caching. Then you end up with 4,300 gigabytes of traffic that you could potentially save with this. According to the Federal Environmental Office, we need about 5,000 watt-hours of energy to send a gigabyte of data. If I put this into my calculation now, then I end up with 15,000 watt-hours of energy that I could save with these measures. That's about 10 single households of energy usage. So pretty big numbers we're talking about here. That's about 7 tons of CO2 emissions that we could save each month with this measure. So how much is 7 tons actually? With 7 tons of CO2 budget, you could fly from Hamburg to London 16 times return. So that's really a large amount of CO2 that we're saving by compressing this logo, which only takes about 2 minutes. But this is of course not the only thing you could do. Videos are a huge part of the global data transmissions. About 60% of the worldwide data transmissions are video. So video on demand is 34%, 13% alone are just Netflix. That's a big number. Pornography with 27% is a big topic as well. So maybe you can think about that this evening. To keep this in mind, there is a nice tool also made by the Green Web Foundation, co-developed by Chris Adams. Everybody of you probably knows Lighthouse if you're into web development. To test your website on different parameters. And what this foundation has developed is called Greenhouse. And additionally to the other factors that Google is looking at anyway, we also now calculate a sustainability score so that you can automatically test your website on sustainability. But also Apple has now a feature in its Safari browser. They added a feature